This next question is a rational expression word problem question. A group of friends went out for some dinner. The bill came to $120 and all of the friends agreed to split the bill so everyone paid the same amount. However, 3 friends forgot their wallet, so the rest had to pay an additional $2 to cover the entire cost. We want to know how many people went out to dinner initially. So 3 of these people did the old oops, I forgot my wallet routine. Very hard to believe, perhaps. Maybe they don't get invited out the next time. But what ends up happening is the rest of the friends have to pick up for what the other 3 weren't able to pay. So we want to know what the variables are in this situation. Well, one of the variables is going to be total price of the dinner, because it tells us the bill came to $120. One of the variables is going to be the price per person, because the question tells us each of the rest had to pay an additional $2 per person. And one of the variables is going to be the number of people who went out to dinner, because that's what the question's asking us for. So we can get those 3 variables into a relationship: the number of people who went out to dinner, the cost per person, and the total cost. I like to put these into a pyramid where we can say that the price per friend is equal to the total price over the number of people who paid. Some people don't like this pyramid because they feel that we should be able to do these steps algebraically. I agree to a point. I agree that if the price per friend equals the total price over the number of people who paid, that we should be able to rearrange that equation and say that the number of people who paid is equal to the total price over the price per friend. And similarly, we should be able to rearrange the equation to say that the total price is equal to the price per friend times the number of people who paid. Having said that, I do like the visual. The visual does help me to answer this question, so we'll use the pyramid in this solution. Now, we also want to know what our 2 scenarios are. In this case, the scenario 1 is the scenario where all friends pay. And what's interesting about this question is scenario 1 is a scenario that never actually happened. It isn't true that all friends actually paid. However, the question is worded in such a way that the situation that did occur is compared to what would have happened had they all paid. 3 of her friends forgot their wallet, so the rest had to pay an additional $2. A comparison is being made between the actual payment that occurred and what would have happened had everyone brought their wallet. So we're going to use scenario 1 as something that in fact never actually happened. It's an imaginary scenario. Scenario 2 will be the scenario that actually did happen, where 3 friends failed to bring their wallet and failed to pay. So we ask ourselves, ultimately, what is this question asking us for? Ultimately, it's saying how many people went out to dinner initially. So to keep our solution simple and straightforward, we'll say let X be the number of friends who went out for dinner initially. And we'll deal with our 3 variables of total price measured in dollars, price per friend measured in dollars per friend, and the number of payers measured in friends. And we will consider our 2 scenarios, one being if everyone paid and one being if 3 don't pay. Then we'll consider the value for each variable under each of the scenarios. Well, the total price is $120 regardless if everyone pays or if 3 people don't. Now, the number of people who pay in the imaginary scenario would have been X. We know that because X is the number of people who went out for dinner. So if everyone paid, X people would have paid. In reality, though, 3 people didn't. So 3 less than X actually did pay. So in the scenario that actually did occur, if 3 people don't pay, the number of payers is the total number of people who went out to dinner minus 3. The price per friend is unknown, but we should be able to make a formula, or an equation out of, involving these 2 variables, the variable of price per friend in the 2 different scenarios. And so we think about it a bit and we say, okay, if everybody had paid, the price would have been cheaper by $2. So that means if we add $2 to what the price would have been if everyone paid, we would get the price that actually occurred where 3 people didn't. So the price per person if each person pays plus 2 is equal to the price per person if 3 people don't pay. Well, the price per person if everyone paid is 120 over x, because we go back to our triangle. The price per person if everyone paid is the total price over the number of payers. So 120 over x. When we take 120 over x and add 2, we'll get 120 over x minus 3. And that is our rational expression equation. We then have to consider what our lowest common denominator is in this case, and our lowest common denominator is x times x minus 3. But we have to also keep in mind that x cannot equal 0 and x cannot equal 3. Those are our restrictions. If our final solution conflicts with one of those restrictions, it's not actually a solution. Fortunately for us, that doesn't occur in this case. So we go to the next line, and what we're going to do is take our original equation and put each rational expression over the same denominator. So 120 over x becomes 120 times x minus 3 over x times x minus 3. 2 becomes 2x times x minus 3 over x times x minus 3. And 120 over x minus 3 becomes 120x over x times x minus 3. What we then do is multiply each one of those rational expressions by the denominator. And we can do this because we've already considered the restrictions. That has the effect of clearing the denominators out. So in a sense, what we do is we get each rational expression over a common denominator, and then we ignore the common denominator and focus just on the numerator. We expand that out, and we get this equation here, and then we recognize it as a quadratic. If we want to be a quadratic hero, we're going to let one side equal 0. So we are able to say 2x squared minus 6x minus 360 equals 0. We use common factoring first. X squared minus 3x minus 180 equals 0 now. And we factor. X minus 15 times x plus 2 equals 0. From here we can say that either x equals 15 or x equals negative 12. Well, it's an extraneous solution to say x equals negative 12 because there's no way negative 12 people go out for dinner. So x equals 15, and we can say that 15 people went to dinner. This does not conflict with one of our restrictions. If we go back and just ask ourselves if this makes sense. So suppose everybody paid. Well, then 120 divided by 15 would be 8. However, 3 people forgot their wallet, which means only 12 people paid. 120 divided by 12 is 10. Each of those people had to pay an additional $2. So we got the right answer.